Hi students, welcome to today's class. I hope that today all of you wrote the exam very well, and those who are writing for examinations tomorrow, I hope that all the best for you. So to help you something in preparing mathematics, I am here with came some with some very good number of problems, even though they were not asked in previous year JEE mains examinations. These models are very important. Okay now, so try to understand these problems, then how to solve these problems, what are the techniques that we applied, how to proceed, how to attack the problems. Okay, so that all those things, see the problem solving techniques. Okay now, so see the first problem here. So the value of limit extends to 1, x square minus 1 into sine square pi x upon x to the power of 4 minus 2x cube plus 2x square minus 1. So this is a problem from limit concept. So options are also available. So generally first thing what we will do, as a limit extends to 1, wherever x is there we will substitute 1. So this is a 1 square, 1 minus 1 0 sine pi, that is 0, 1 minus 2 plus 2 minus 1, denominator is also 0. So we are getting 0 by 0 form. So we are getting 0 by 0. Generally students, they immediately thought of doing a L'Hospital rule. Okay, if you apply the L'Hospital rule, it takes, even though it shortcut method L'Hospital rule, but here in this case the problem will become very lengthy. Why? Because here see here x to the power of 4 is there. So x to the power of 4, again 4x cube, again you have to substitute in the numerator. You will get in the numerator you will get by parts formula, u into v formula, like that you will get. Okay, so without doing that, can we directly solve this problem? Yes, we can solve this directly. See here, first observe the denominator. So whatever may be the simplification we will do, the numerator is very clear. So let us see the denominator first here. So what is the denominator? F of x is equal to x power 4 minus 2x cube plus 2x minus 1. Let us do the factors here. So first you substitute 1. So 1 minus 2 plus 2 minus 1, 0. Therefore x minus 1 is a factor. Let us substitute f of minus 1. This is equal to 1. This is plus 2 minus 2 minus 1. This is also 0. This is x plus 1 is another factor. So x minus 1, x plus 1, two factors are there. Therefore x square minus 1 is a factor. X square minus 1 is a factor. Therefore, so you divide x to the power of 4 minus 2x cube plus 2x square minus with x square minus 1 using using Horner's method of synthetic division. So here what is the coefficient here? 1 minus 2, here x square is there, not there, 0, 2 minus 1. So what is the first factor? X is equal to 1, 0, 1. So therefore 1 minus 1 minus 1. So minus 1 minus 1, 1, 1, remainder 0. Again x is equal to minus 1. X is equal to minus 1, 0, 1, minus 1, minus 2. So here 2. So this is a 1 minus 1, remainder 0. This is x square minus 2x plus 1. So this is a x minus 1 whole square. X minus 1 whole square. So altogether, so finally what is our problem? So limit extends to 1. X square minus 1 into sine square pi x divided by, what are the factors of the denominator? So this is equal to x square minus 1 into x minus 1 whole square. X square minus 1 into x square minus 1. So clearly as x tends to 1, as x is not equal to 1, therefore these two can be cancelled. Now see the problem, remaining problem. From that only we have to get the answer. Here numerator square is there, denominator is also square is there, whole square we will write down. So that is equal to, first thing we will do that. So this is equal to sine pi x by x minus 1 whole square we will write down. Understand? Next what we have to do? Now immediately we have to think of the formula, limit extends to 0, sin x by x value is equal to 1. Then how to think here? So here limit extends to 0. See here, sin pi x Sin pi x is same as sin of pi x minus pi. Can I write it as sin 180 minus theta? So you can put no problem. Pi x minus pi. Even though if you take minus will come outside, minus 1 whole square plus 1 only. Sin 180 minus theta, sin theta. So this is equal to, here also you multiply the numerator and denominator with the pi. So this is equal to pi x minus pi here into pi whole square. Understand this? So take the pi common, pi will get cancelled. Okay now. So this is the adjustment I did. So therefore limit extends to 0. Sin pi x by x means up to here how much answer? 1 you will get according to the identity we have. So this is equal to pi square. Pi square we will get. Understand this? Therefore option C is the correct answer. So here the students, they will do the problem up to here. Up to here they will do. From here onwards they will struggle to do it. Okay now. So otherwise if you didn't get this idea, so you can do the here in this stage you can do L'Hospital rule, no problem. Sin square pi x. So sin square pi x means what is the derivative? So this is equal to 2 sin pi x. Sin pi x derivative cos pi x. Again cos pi x derivative pi by this is a 2 times x minus 1. 2 times x minus 1. So here 2 will get cancelled. Again you do the, otherwise don't do cancel, sin 2 pi x. Sin 2 pi x you do. Again you will do the cancel. Then 2 will cancel. You will get a pi here. Here denominator 1. Already pi is there. Pi into pi square. Like that also you can do. Using L'Hospital rule also you can do up to here. Otherwise if you have got the idea, pi x can be written as a pi x minus pi, then automatically the answer will come. Okay now. So I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. So this is a problem from complex numbers. If alpha and beta are different complex numbers with the modulus of b is equal to 1, then the value of modulus of beta minus alpha by 1 minus alpha conjugate alpha into beta. What is the value of this? Then how to proceed this problem? See here, whenever modulus of beta is given, so whatever may be the modulus of beta or modulus of alpha, it is a unimodular complex number. Unimodular means the modulus is equal to 1. Then immediately we have to think of b into beta complement is equal to 1. B into its conjugate. Modulus of b is equal to means what? B into b conjugate. Okay now? Right. Then so this implies b is equal to 1 by beta conjugate. B is equal to 1 by beta conjugate. So wherever b is there, we can substitute in that 1 by beta conjugate. Now let us see the problem. Now what is the problem? Beta minus alpha by 1 minus alpha conjugate beta. So in place of beta, write down 1 by beta conjugate. That is equal to 1 by beta conjugate minus alpha by 1 minus alpha conjugate into beta. Now let us take the LCM here. So if you take LCM, what happens? 1 by beta conjugate, you will get it come into outside. This is equal to 1 minus alpha beta conjugate by 1 minus alpha beta. 1 minus alpha conjugate into beta. So this modulus will come in the numerator and denominator. So this is equal to modulus of 1 is 1 by beta conjugate. So this is equal to 1 minus alpha beta conjugate by 1 minus alpha conjugate into beta. Already we know that modulus of beta is equal to 1. So if it is a modulus of x is equal to modulus of x bar, we know that modulus of z is equal to modulus of z bar, both are same. So if it is a modulus of beta is equal to 1, modulus of b conjugate is also 1, on the whole its value is 1. So its value is 1. So leave it like that. And one more thing, we have one concept. What the concept is? Same concept. Modulus of z is same as modulus of z conjugate. For both things modulus are same. So then it is equal to, I can write down 1 minus alpha beta conjugate divided by same denominator I will write down as it is. Understand? Understand this. Okay, next one, this conjugate will come for both the terms. So then it will become 1 minus alpha conjugate into beta by 1 minus alpha conjugate into beta. 1 minus alpha conjugate beta by 1 minus alpha conjugate beta. So both will get cancelled, you will get 1. So the value of the given complex number, modulus of that complex number is equal to 1. Okay now. So here various concepts we have used. The first concept is modulus of beta is equal to 1, then b into beta conjugate is equal to 1. That is the concept we used here. And here we used here modulus of z is equal to modulus of z conjugate. We used that concept. Okay. So for both the concept we got the answer. Okay. I hope that you understand this solution. Let us go to next problem. Hi students, welcome to this problem. So see this problem, the value of limit extends to 0, 5 sin x minus 7 sin 2x plus 3 sin 3x by x square into sin x. So if you substitute x is equal to 0, obviously you will get a 0 by 0, and you can do this problem using L'Hospital rule also you can do, but here u into v formula you will get, thereby again I think you are asked to, you have to do the, once again you have to do the L'Hospital rule. Okay. So without using L'Hospital rule, there is a very simple method is there to solve this problem. So the simple method is there, that means you have to know the expansion of sin x. So what is the expansion of sin x? So this is equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus x power 9 by 9 factorial minus it will go on so on. Okay na? So this is equal to, put it in the box. Put it in the box. Okay. So this is the expansion we have. So let us write the expansion for the given problem also. So this is equal to limit extends to 0, 5 into sin x means x minus x cube by 3x plus x to the power of 5 by 5 factorial minus so on. Don't write down full. So minus 7 into sin 2x means what? Wherever x is there, substitute 2x. So that is equal to 2x minus 2x whole cube by 3 factorial plus 2x whole to the power of 5 by 5 factorial so on. Okay now. Next plus 3 into sin 3x. Sin 3x means how much? This is a 3x minus 3x whole cube by 3 factorial plus 3x whole to the power of 5 by 5 factorial minus so on. Okay now. Whole divided by x square into, what is the sin x expansion? Sin x expansion is x minus x cube by 3 factorial, x to the power of 5 by 5 factorial, so on. Okay now. So here just what is the first step is, we wrote the expansion. Okay. So observe here, 5 into x, 5x, 7 2s are 14x here. So this is a 5x, this is a minus 14x, this is a 3 3s are 9x. So this is a 5x plus 9x, 5 plus 9 14 minus 14. Up to here it will be cancelled. Now what are the terms remains here? See here, denominator you can take x common outside. Here x, x cube, x power 4, x you can take. See here what we will get, already x square is there. X square into x, x to the x cube. So in the numerator, write the terms up to x cube only. Remaining all will become 0. Why? Because here x to the power of 5 by x cube, x square will come. Limit extends to 0 means if you substitute x is equal to 0, those terms will become 0. Okay now. So first write down the first term only you write down. So here how much you will remains? Minus 5 by 3 factorial means 9x cube. No need to write down here. No need to x to the power of 5 term, no need. Why? Because here x cube will come, it will get cancelled, it will become 0. So minus 5 by 6 x cube, enough. Minus, see here, already this term is cancelled, 2 cube 8, 2 cube 8, 7 8s are 56, already minus outside is there. So this is equal to 56 by 3 factorial means 6 into x cube, x cube. So remaining terms no need to write down, okay, so leave it. So this is the next term. Next here 3 cube 27, 3 cube is equal to how much? 27, 27 3s are 81. So this is equal to minus 81 by 3 factorial means how much? Is 6 into x cube, okay. So remaining terms no need, so divided by, so here you take common outside x cube, you take x common outside, then already x square is there. So 1 minus x square by 3 factorial, x to the power of 4 by 5 factorial, so on, okay na. So of course this is a limit x tends to 0, okay na, right. So in the numerator x cube, you can take x cube common outside, denominator also x cube is there, x cube cancel, x tends to 0, 0, 0, 0, all will become 0. So this is ultimately how much you will get? Minus 5 by 6 plus 56 by 6 minus 81 by 6. This is the thing we will get. So minus 5 by 6 plus 56 by 6 minus 81 by 6. So if you do this cancellation, you will get minus 5. So minus 5 will be the correct answer, okay now. So this problem, of course, you can do this using L-Hospital rule, no problem. But using the sin x formula also you can do within 2 steps. Only this step and second step. Third step is your answer. Only third step is also. So try to do the problems using this expansion also. Okay now? Right. I hope that you understand this solution. So let us go to next problem. Hi students, welcome to this problem. So this is problems from series and sequence. See the first problem. See here the 3 non-zero numbers A, B, C are in AP, arithmetic progression. Very clear. These 3 numbers are in arithmetic progression. Next, second condition is increasing A by 1. That means if you increase the A by 1, that means A plus 1, or increasing the C by 2. That means if you increase the C by 2, that means if you make the C as a C plus 2, the numbers are in GP. The numbers are in GP. The value of B is. Okay, so don't underestimate this problem, so we can solve it. But this type of small problems are also giving in the examinations. Okay, so let us see this condition. First, given condition, write it in the equation form. First, A, B, C are in AP. So clearly, 2B is equal to A plus C. Call it as first equation 1. Now, what is next one? Increasing A by 1. That means what? A plus 1, B, C. They are in GP, geometric progression. So geometric progression, we know that B square is equal to A plus 1 into C. Call it as second equation. Next condition is increasing C by 2. That means what? A comma B comma C plus 2. This is in geometric progression. This also in geometric progression. Therefore, B square is equal to A into C plus 2. Call it as third equation. That's all. We know 3 equations. 1, 2, 3. Anyhow, we have to solve value of B. So from this, you can apply any method as your wish. Any method as your wish. The answer should be, final answer should be the same. Then how to proceed? Very simple techniques here. Second equation and third equation. Both are B square and B square. So left hand side parts are equal. Can we equate right hand side parts? Yes, we can equate. Therefore, A plus 1 into C is equal to A into C plus 2. Right. Any more thing cancel. So see here, multiply inside. AC plus C is equal to AC plus 2A. Right. So here AC we can cancel. C is equal to 2A. We got a relation between C and A. C is equal to 2A. Then what we will do? Substitute this C is equal to 2A in the first equation. Let us see what happens. So this is equal to 2B is equal to A. 2B is equal to A plus. C is equal to how much? 2A. That means 2B is equal to 3A. Therefore, B is equal to 3A by 2. So we got a relation between B and A. We got a relation between C and A. We got a relation between B and A. Now in the second equation, in place of B, substitute 3A by 2. So this is equal to 9A square by 4 is equal to A plus 1 into. In place of C, write down 2A. In place of C, write down 2A. Understand? Now we got an equation in A. So since A is not non-zero numbers, A cannot be equal to 0. Therefore, we can divide with A on both sides. That means you can cancel. So this is equal to 9A is equal to A plus 1 into. This is equal to 16. Understand? So this is equal to 9A. 4 2s are 8. This is equal to 8. Why? Because 1A will be cancelled. So this is equal to 9A, this is a 8A. So therefore A is equal to 8. 8A, it will come 8. So 1 into 8. A is equal to 8. Now we want B value. That's why B is equal to 3 by 2. B is equal to 3 by 2 into A. A means 8. So 2 1s are 2 4s are. B is equal to 12. Therefore B answer is 12. So if you ask C value, C is equal to 2 into A. 2 into 8, 16. C is equal to 16. Okay, na? So like that, we can get the answer. Very simple problem. Okay, so concentrate. This type of problems are also. Okay, na? Right. So here both the conditions, general students will get confused here. If it is a R is there, then we have to make use of only these two equations, or 1 and 3 only we have to use. Like that, they will start thinking, no, it's not. R means and. R means it is given, then means it is and. Okay, na? So these two equations together we have to use. Okay. I hope that you understand this solution. Let us move to next problem. Hi students, welcome to this problem. So see here, this is from integral. So indefinite integral. So integral of x to the power of 3m plus x to the power of 2m plus x to the power of m into 2 into x to the power of 2m plus 3 into x to the power of m plus 6 whole to the power of 1 by m dx. What is the value of this integral? See here, this type of problems, our mind will become blank. So how to solve, how to proceed? There are certain problems are there that we have to get an idea. That's all. There is a nothing, short tricks, nothing is there. So we have to get that idea. What is the idea is here? So x power 3m plus x power 2m plus x power m. Divide this expression into x. Divide this expression into x. So that you have to multiply x. 2 into x power 2m plus 3 into x power m plus 6 whole to the power of 1 by m dx. The first thing I did is multiply and divide with x. Okay, now so this becomes a power m by a power n, a power m minus n. So this is equal to x power 3m minus 1 plus x power 2m minus 1 x power m minus 1. A power m by, this is x power 1, a power m by a power n, a power m minus n. Now here x you multiply inside. See here, but his whole to the power of 1 by m is there. That means we can write it as a x power m whole power m 1 by m. Then this whole power 1 by m will come. Now you have to multiply with x power m inside. Then it becomes 2 into x to the power of x power m into x power m. This is x power 3m. 3 into x power 2m. 6 into x power m whole power 1 by m dx. Understand this? This is the thing. Now if you observe anything you observed here. So observe here. X power 3m. What is the derivative of x power 3m? 3m into x to the power of 3m minus 1. You go 3m minus 1. What is the derivative of x power 2m? 2m into x to the power of 2m minus 1. X to the power of 2m minus 1. What is the derivative of x power m? M into x to the power of m minus 1. X to the power of m minus 1. That's why this whole thing you call it as a t. 2 into x to the power of 3m plus 3 into x to the power of 2m plus 6 into x to the power of m. You call it as t. Understand? Understand this. Now differentiate with respect to x on both sides. So this is equal to 6m into x to the power of 3m minus 1 plus this is equal to 6m x to the power of 2m minus 1 plus this is a 6m x to the power of m minus 1 into dx is equal to dt. 6m, we can take 6m common outside, let us send to that side. So, this is equal to x to the power of 3m minus 1, x to the power of 2m minus 1, x to the power of m minus 1 into dx is equal to 1 by 6m into dt. Okay, now. So, from this value and this value we can write down 1 by 6m dt, and this will become t to the power of 1 by m. Okay, now. From this we can do the calculation. Okay. So, let us continue the solution. Welcome back to this calculation. See here, up to here what we can write down 1 by 6m dt. So, that means integral of this whole thing is we taken as a t to the power of 1 by m into 1 by 6m dt. So, therefore, take 1 by 6m is a constant outside, 1 by 6m into t to the power of 1 by m dt. So, this is equal to 1 by 6 into t power 1 by m plus 1 by m plus 1, of course, plus c. Okay, if you take a LCM here 1 plus m will get cancelled. So, this is equal to 1 by 6 into what is your t? So, this whole thing we taken as a t. That means 2 into x to the power of 3m plus 3 into x to the power of 2m plus 6 into x to the power of m whole to the power of 1 plus m by m divided by 1 plus m plus c. This will be your final answer. That will be your final answer. The only thing to do this problem is, in the given problem, multiply the and divide with x. Okay. So, 1x you multiply the second factor, 1x you divide with the first factor, automatically you will get the idea. So, that idea automatically you will get if you go on solving the various problems. Okay. Right. So, I hope that you enjoyed today's class with some more problems, and tomorrow's class I will stand before you. So, until then, all the best.